Welcome to National Resource Center in Marine Science. Today we will discuss about Antarctica, which is one of the very extreme land on Earth, and how it's behaving due to the changing climate and its role in the global system. Antarctica has many facets, but why do we want to study Antarctica? Most of us do understand and believe now that the global warming is for real, and the globe is warming. Nearly 1 degree Celsius it is warm from the prehistoric region, and the warming has been very substantial, happening since the industrial revolution. And if you look at this particular graph, you can very well establish actually that warming is very serious, and it's been happening as well as also engrossed within the natural variations. However, this warming is real, of course, but what are the causes and factors involved for this global warming? There have been many studies, many theories discussing whether we are seeing the variations are due to natural variability or it's due to the human interference. This particular modeling study, when it together with the observations of the climate data, clearly mentions or clearly support the fact that what we see is everything is not natural variability. In this figure, the black line represents the observations, the blue line represents the modeled record of the natural climate variability, and the red one is due to anthropogenic factors, mainly the radiative forcing line. And when we put all these factors together, the natural as well as the anthropogenic factors, we can see that they are better matched with the ongoing variability. So it's very obvious and clear that there is a significant amount of anthropogenic influence on the climate system. The Intergovernmental Panel on Climate Change, which is the prime body which has a large number of countries contributing to it, and more than 100 scientists work for it to produce these reports, what they call actually the assessment reports. The last assessment report, which happened in 2013, called the Assessment Report 5, ER5, which clearly warned that the globe is warming and we need to take action. In fact, the Paris Agreement was based on that. However, subsequently things have not been really working well, so they came with another report, which is actually an interim special report on the global warming, when it could be about 1.5 degrees Celsius warming and how it's going to affect the globe. This report came in only 8th October 2018, which has several recommendations, several alarming facts within that, and few of them which are relevant to this particular talk today is: one is that the human activities are estimated to have caused about 1 degree Celsius warming, global warming above the pre-industrial levels, and it's likely to reach 1.5 degrees Celsius between 2030 and 2050. And if it continues to increase at the current rate, and this is with a very high confidence, they state. And the warming is greater than the global average, annual average, in many parts of the land regions. That's very important. So it is not a uniform variability what you see on the Earth. There are areas which are 2 to 3 times warmer than the rest of the regions, like for example Arctic. And also generally the warming is higher on land compared to that of the ocean. The warming from anthropogenic emissions, what we see today, that will persist for at least thousands of years and will cause further long-term damage, such as the sea level change and its associated impacts. And all these statements are with very high confidence. There are various other things which we will not discuss. This has very implications to the Antarctic research. So when we say that the globe is warming and some parts are warming more than the other part, which are those some parts? This one picture clearly shows you that the red color, which is the warmest part, which shows warming about nearly 4 degrees Celsius, and then the lighter ones shows the cooler ones. You see that the entire Arctic region, the northern hemisphere, North Pole area is completely red, which clearly say that the Arctic is warming much bigger than compared to the tropics. Also, some part of the Antarctica is also warming. If you look at the one of the picture, what you see in the middle, the inset, you can see that the warming is very high in the Arctic and there is a smaller peak in the Antarctic. The rest of the areas is relatively less. So what we can make out from this is actually that the polar regions are warming much more compared to the rest of the world. This is what they call as the polar amplification. The polar amplification have many reasons. One of the major reasons is thought to be primarily from the positive feedback, because as the warming, the ice get exposed and the ocean is seen, and ocean being highly absorbing nature compared to ice, which is highly reflective, we find the ocean is absorbing a lot of solar radiation, making it a positive feedback, increasing the again warming in that part of the region. That is something which is seriously what we are seeing, and what we are seeing in Arctic, especially the retreat of the sea ice in that region. To understand how this behavior of this globe in the warming conditions happening, we should better understand the Earth system altogether. Earth consists of major 5 spheres: the lithosphere, the land which we live on; the hydrosphere, the ocean, which is nearly about 70% of the land surface; and the atmosphere, which provides us the oxygen as well as interact with the lithosphere and ocean and rest of the world; and biosphere, which is a very huge sphere of life, which is there on land, ocean, atmosphere, everywhere. And then there is one more sphere called cryosphere, which is that part of the Earth's surface where water is in frozen form. This is mainly in the polar regions like Antarctic, Arctic, and the glaciers over the Himalaya, the mountains, various mountains. And they have a very significant role, but unfortunately they are the least studied. So that's what we will be discussing today. The cryosphere is those portions of Earth's surface where water is in solid form, including snow cover, glaciers, ice caps, ice sheets, sea ice, lake ice, river ice, and even permanently frozen land, what we call as the permafrost. Mainly the Greenland and Antarctica are the major cryospheric regions, which consist about 75% of the world's fresh water and enough to raise about sea level by nearly 70 meters. It is an extremely high volume of water which is frozen on these regions. The polar regions are mainly two. You have Antarctica and Arctic. Antarctica in the southern hemisphere, and Antarctica is a land continent surrounded by the ocean, and the Arctic is the ocean surrounded by the continents. And then there is another pole, what we call as a third pole, which is essentially the Himalaya, Tibetan, Karakoram region, which contains the world's largest or the highest mountains, including all 14 peaks above 8,000 meters. It's also the major 10 rivers on the world and forms a formidable global ecological buffer. Why are these polar regions so important? We should understand that the large system like Earth behaves the way it is today because of the polar regions, because the processes of the Earth are modulated by the poles. We will come back to that later. And the climate change impacts are first visible and are most dramatic at the poles. And poles are most vulnerable parts of the Earth's surface, especially in a warming world. And they are home to amazing life forms and adaptations. It has extreme conditions, pristine environment, and unique ecosystem. And more than 80% of the Earth's fresh water is locked on these polar regions. And they are also even economically very vital for the future of the mankind, because there is a huge amount of hydrocarbon, especially in the Arctic region, and minerals, fisheries, and even for the shipping industry. And this picture tells you why poles are so important. I call actually the poles as the pacemakers of the Earth system. It provides the arteries and the veins of the Earth system, require the blood circulation, what we call actually the global oceanic circulation. The major circulation is produced at the North Atlantic and the Arctic region and near the Weddell Sea in the Antarctic region. And this provides the deep water masses which circulate all around the globe and controls the oceanic currents and in turn the weather systems. Next most important, very critical part of the importance of the polar regions is that its contribution to global sea level. If we look at the different the glaciers, ice caps on the mountains, in the Arctic region, in the Greenland and in Antarctica, we find that from the assessment report of IPCC in 2007 to the assessment report 5 in 2013, there is a dramatic change in most of these values. Mainly because it's not just because actually there have been only warming, but also because there have been really lack of data. And we find there's a significant and very dramatic increase happening in Greenland. And by the AR6, that assessment report 6, which is going to come in 2022, this is an area which will have a very huge difference in increase in sea level change due to the warming of the real polar regions like Greenland and Antarctica. If you look at Antarctica itself, the contribution was considered to be extremely low during the 2007 report. When it came to 2013 report, they found that there is significant error is there in that, and the increase is quite substantial. And we believe by 2022 AR6 report, it could be even much higher, because Antarctica is really warming. Many of the ice shelves are getting lost. When we come back, we will try to study more about Antarctica, what is its real importance, how different it is, and how it is controlling the global system, and how it's being affected by what's going around the globe.